Hello everyone. In this video, we are going to evaluate trigonometric functions using the special right triangle. And this is the first part. Before we go over this example right here, let's have a review on special right triangle and formulas to find the reference angles. We remember that special right triangles, which includes the 30, 60, 90 degree triangle and the 45, 45, 90 degree triangle, and the formulas to find for the reference angle are very important in evaluating trigonometric functions. Now let's go over the special right triangles here. We remember that for the 30, 60, 90 degree triangle, the opposite of 60 is square root of 3 over 2. While the adjacent of 60 is 1/2 and the hypotenuse is 1. Now, for the 30, the opposite of 30 is 1/2 and then the adjacent of 30 is square root of 3 over 2 and then the hypotenuse is 1. Now, for the 45, 45, 90 degree triangle, the two legs are equal, which is having a value of square root of 2 over 2, and the hypotenuse is 1. Going over the formulas for the reference angle, we remember that these formulas that we have here is applicable if the angle is greater than or equal to 0 or less than or equal to 360. Okay, so let's go over the problem here. We're supposed to determine the exact value of sine 60. In order that we can determine the exact value for this, there are steps that we need to follow. The first step is, using the given angle, sketch and label the special right triangle on the unit circle. Since it says that it is 60 degrees, so we can go ahead and say that we can approximate this to be 60 degrees right here. So this is our 60 degree angle right here on this corner. So I'm just going to label that as 60 and this one right here is 90. So we have this special right triangle right here. Now we are supposed to label this. We remember that across the 60 is square root of 3 over 2 and adjacent to the 60 is 1/2. Now, since this is on the first quadrant, you can see that this 60 degrees is on the first quadrant. The x value, so this value right here, the x is positive, and the y value, this value right here, remember x is the horizontal axis and then the y is the vertical axis. So the horizontal value for this would be positive, and then the vertical value, which is the y, is also positive. So that we can go ahead and move on to the second step. We determine the reference angle and determine the exact value of the angle that we're looking for. So in this problem right here, our reference angles, we can go ahead and write that down here. So our reference angle is actually 60 since we are already on the first quadrant. So that is 60 degrees. Since we are looking for sine, we are going to use again the acronym SOHCAHTOA. Since this is sine, we're going to use the SO. So we're going to use the SO to determine the sine. And then again, remember this SO stands for sine is equal to opposite over hypotenuse. So we can go ahead and write down sine of 60 degrees is equal to the opposite to the 60 here is positive square root of 3 over 2, and then the hypotenuse is, remember for the unit circle, the hypotenuse is always 1, so then this is over 1, so that we can go ahead and say that sine 60, simplifying this, would come out to be square root of 3 over 2. This is the exact value for sine 60. So I'm just gonna write that up here. Now let's move on to the next example. So in here, we're supposed to determine the exact value of cosine 135. So again, there are steps that we need to follow. The first step is using the given angle, sketch and label the special right triangle on the unit circle. It says that it is 135. So we start from the positive x-axis here. This is 90. and 135 means it's somewhere in between 180 and 90. So I can go ahead and approximate this to be 135 right here. So again, this is 135 degrees. And so we can go ahead and say that we gonna create the right triangle right here. So we are going to move on to the second step. The second step is to determine the reference angle and determine the exact value of the angles that we're looking for. So then we can go ahead and say that since this is on the second quadrant, the formula for the reference angle would be equal to, that's gonna be 180 minus the given angle. So the given angle is 135. So that is 180 minus 135. So then our reference angle is 45 degrees. This means that this corner that we have right here is 45 degrees. So I'm just going to label that as 45 degrees right there. So we remember that the side across from 45 degrees would be square root of 2 over 2. And then the other side also would be equal to that since both angles are the same. So this would be square root of 2 over 2. And this hypotenuse right here is 1. Since this is on the second quadrant, our x, which corresponds to the horizontal line here, this represents the x. Our x here is negative. And our y right here, the vertical line right here, is actually parallel to the positive y-axis. So this is positive. So that we can go ahead and use the acronym SOHCAHTOA, that is cosine. So we're going to use the CA. CA means cosine is equal to adjacent over the hypotenuse. So we can go ahead and set this up as cosine of 135 degrees is equal to adjacent. So the adjacent of 45 is negative square root of 2 over 2. So I'm just going to write that up here. So negative square root of 2 over 2 over the hypotenuse, which is 1. So negative square root of 2 over 2 divided by 1 is just negative square root of 2 over 2. So this is the exact value for cosine 135. So I'm just gonna write that up here. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. We're supposed to determine the exact value of tangent 210 degrees. Again, there are steps that we need to follow. The first step is using the given angle 210, sketch and label the special right triangle on the unit circle. So 210, this is 0, this is 90, this is 180, so it should be over 180. So we can approximate this to be located somewhere around here. So this is the measure for 210. So from this side all the way to this side is 210 degrees. Now we are going to create this right triangle right here. Now the second step is to determine the reference angle and determine the exact value of the angle that we're looking for. So since this is on the third quadrant, our reference angle formula would be, that's gonna be the given angle on the third quadrant minus 180. So then our given angle is 210, so 210 minus 180, and that is 30. This means that this angle that we have right here is 30 degrees. So that makes sense because if this is 210 and that's 180 right there, so this remainder right here is actually 30 degrees. Now we remember that across the 30 degrees is actually 1/2. So the measure for this is 1/2. And then adjacent to 30 degrees is square root of 3 over 2. Since this is on the third quadrant, our x right here is on the negative side. So the horizontal line right here, which is adjacent to 30, would be negative. while the line across from 30, which is parallel to the negative y-axis, would be negative 1/2. So then our hypotenuse here, since this is a unit circle, is 1. So we are supposed to determine tangent 210. So we're going to use the acronym SOHCAHTOA. So we're going to use the TOA. TOA means tangent equals opposite over adjacent. So we can go ahead and write tangent 210 degrees equals the opposite of the 30, not the 210, but the 30. So the opposite to that is negative 1/2. And then the adjacent to this 30 is negative square root of 3 over 2. Since this is a complex fraction, what we do is we flip the denominator and multiply across. So this would come out negative 1/2 times, flip this, that would be negative 2 over square root of 3. So then we can go ahead and multiply them across. We can cross the 2 out. So we are left with 1 over square root of 3. Now, what are we going to do is we are going to rationalize the denominator since this is square root of 3. Remember, when we rationalize, so if we have 1 over square root of 3, when we want to rationalize this, we are going to multiply square root of 3 times square root of 3. And so this would come out 1 times square root of 3 is square root of 3. Square root of 3 times square root of 3 is square root of 9. And square root of 9 is 3. So then that is square root of 3 over 3. And the value here is positive because when we multiply or divide two negatives, the answer would be positive. So this is the exact value for tangent 210. So I'm just going to write that up here. So that is square root of 3 over 3. Did you get the same answer as this? Good. Perfect. Now let's move on to the next problem right here. In this problem, we're supposed to determine the exact value of sine 330. Again, there are steps that we need to follow. The first step is using the given angle, sketch and label the special right triangle on the unit circle. So 330, we remember that this is all the way to here is 90, all the way here is 180, all the way here is 270, and we wanted 330, so we can go ahead and approximate it to be located somewhere around here. So that means from here all the way to this side is 330 degrees. So we are going to label the special right triangle right here. So we determine this angle right here by moving on to the second step. The second step tells us that we are supposed to determine the reference angle and determine the exact value of the angle that we're looking for. So since this is on the fourth quadrant, our reference angle is actually equal to 360 minus the given angle on the fourth quadrant. So that is 360 minus the given angle is 330, which means that our reference angle is 30. And that makes sense because one full circle is 360. So we have 330 right there. So that means the leftover here is 30 degrees. So then we go ahead and label the triangle here. So again, the hypotenuse is 1. We remember that across the 30 is 1/2. And then adjacent to 30 is square root of 3 over 2. And so we can go ahead and label their signs. Since this is on the fourth quadrant, the horizontal line, which is corresponds to the x-axis, is positive, while the vertical line right here corresponds to the negative y-axis. So we can label this as negative. And so we can already solve for sine 330 here. Since we say sine, we then go ahead and use so. So means opposite over hypotenuse. So we can go ahead and write sine 330 is equal to the opposite of 300, the opposite of 30, the one that we're looking for, the reference angle. The opposite of 30 is negative 1/2, while the hypotenuse is 1. So negative 1/2 divided by 1 is negative 1/2. So this is the exact value for sine 330. So I'm just gonna write that up here, negative 1/2. Did you get the same answer as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!